When we think of inventory management, guys, we have to remember that inventory is nothing more than a storage account on the balance sheet. It's storing accumulated costs that we've put into whatever product it is that we're going to try and sell to our customers. And therefore, any amount of labor, material, or allocated overhead that we suspend in the inventory account is literally a grouping of costs waiting to be recaptured when we sell products through the cost of goods sold account. So we want to make sure that we minimize whatever investment we make in inventory relative to our need to have adequate supply to meet our customers' demand. And so it becomes a balancing act of making sure we have sufficient dollars included in inventory to meet demand, yet trying to minimize those dollars attached to inventory. Because if they're suspended in the balance sheet in the form of inventory, that means they are not available for reinvestment elsewhere. So when we come to deciding how much and when we should put product into inventory, we want to make sure we're managing costs, trying to minimize costs, while ensuring sufficient inventory to meet demand. And the costs that we're concerned about really fall into three categories beyond just the investment of labor and materials. If we're going to have inventory on hand that we're not going to sell immediately, that means we're going to have to hold it for a period of time. And that's going to involve certain costs related to maintaining the integrity of that inventory. Could be safety procedures that we undertake, security to avoid theft and pilferage. It could be insurance that we maintain on it. And we're going to call these costs holding costs. They are costs specifically associated with holding inventory. And we usually see those expressed as some percentage of the value of the inventory that we're holding. So that's the first category of costs we want to make sure we're maintaining or managing. The second is going to be ordering costs, because when it comes time to source materials, we're going to have to take the time to invest manpower, materials, etc., to produce the order and deliver. These are going to be known as ordering costs. And as you might imagine, the more we order at any particular time, the less the total ordering cost is per unit. And so we want to make sure that we take the time to try and manage that cost as well by minimizing the number of orders relative to the volume of product we need to minimize the related ordering costs. And the other cost we're going to worry about is going to be either obsolescence or out of stock costs. Those are both costs that are in some respects opportunity in the form of an out of stock cost, as that means a customer is going to purchase from somebody else will lose the opportunity to sell to them. An obsolescence cost becomes literally writing down the value of the inventory that we hold but cannot sell at what we presume to be its full value. Now in our case, we're going to focus principally on managing holding costs and ordering costs and ensuring we have sufficient inventory on hand to meet demand while it's being ordered. And this will be known as lead time or buffer stock. And so we're going to do some work to try and find the order quantity that minimizes the costs associated with inventory in one particular system. It's known as a fixed order quantity system. And that means we're going to monitor inventory on a regular basis. When inventory falls to a particular level, we're going to immediately place an order to replenish inventory to its desired level. That is a little bit different than what we know as a fixed time period system, where we literally just take inventory on a regular temporal sequence, add up what we have on hand, and then place whatever order we need to get back to our desired level. Now, in the case of a fixed order quantity system, we're going to be working towards something called an economic order quantity. That is the quantity that we will order every time we fall to a predetermined level that minimizes the costs associated with holding inventory on hand and the ordering point. EOQ, economic order quantity, is going to be the subject for the next two problems. Now, when it comes time to do any type of EOQ calculation, and again, we're worried about three items. The first is we have to have some idea of our expected demand, because really what we're after here is the ability to develop inventory levels to satisfy the demand we forecast through our supply chain. We recognize that whenever we do that, we're going to always be in a position, or generally in a position, where we have inventory waiting to be sold. And to the extent it's waiting to be sold, we're going to incur holding costs. So it becomes the second critical factor for doing an EOQ calculation. And the third cost we need is that is associated with producing the orders to replenish the inventory. And so anytime we're faced with an EOQ calculation, we're going to need these three critical factors to do it. We're going to need to know this forecast demand over a given period. Could be annual, could be monthly. We just have to make sure we're consistent in how we apply it. Holding costs associated with our inventory, and ordering costs. If we have those three, we usually can get the problems done pretty quickly. And the first problem that we're asked to do for our chapter, problem 1, has to do with Ricky's oranges. Some producer of oranges, fruit, is going to be sold. And we're told in the problem that Ricky's Oranges expects that on an annual basis, they'll be selling 12,500 units. That's our demand forecast, okay? And we're going to categorize that as D. We also know from the problem that every time that Ricky's Oranges produces an order, the order cost is going to be $100 per order. So ordering costs are going to be $100 per order. We're going to designate that by the variable S. And then last, we're told that when it comes time to hold inventory, Ricky's Oranges estimates that holding costs will be 20% of the unit's value, which they estimate to be $50 per unit. And that's going to suggest to us, therefore, that holding costs are going to equal $10 per unit. And we're going to designate that as variable H for our problems. Okay? Now, if we look at this, the derivation of the calculation recognizes that we're going to be incurring holding costs, carrying costs of inventory, and ordering costs over a period of time. And when we look at how that changes over time, we come up with a relationship that can be stated at its most basic the following way, that any economic order quantity is going to be equal to the square root of 2 times annual demand times ordering costs, all divided by holding costs. And in our problem then, we literally are just doing algebra, because we're just going to drop in these factors, where we're going to have 2 times annual demand of 12,500 times our ordering costs, or 100. And we're going to divide that by holding costs per unit, which we've determined is 10. Now we've got a little bit of mathematics to do here to come up with this number, but this is going to be nothing more than the square root of the following. 12,500 annual demand times ordering costs of 100 times 2, or, counting up all our zeros, 2.5 million, 2,500,000 divided by 10. That's going to equal the square root of 250,000, which is going to be 500 units. And so we get the idea there that when we work through this process, every time we order to feed, if you will, into our need to fund 12,500 units, the most economic amount to order is going to be 500 units. That's the so-called EOQ. Now, once we have that, it allows us then to begin to think of what our ordering process is going to be. And the problem asks us in the second part to calculate how many orders, if we follow that EOQ, we will make per year. Well, if we know that our demand is going to be 12,500 units per year, and we're going to have to order those on a regular basis of 500 units per order, that would suggest that we would be making, or placing more appropriately, is 25 orders per year. And pretty simple when we go through this, when we begin to think of it. The last part of the problem actually addresses one other cost that's not included, if you will, in the way this is calculated. And it's the potential cost of not having enough product on hand for demand while we're waiting for an order to be filled. And the next item we want to take a look at here is a calculation of how much it's going to cost us to hold inventory over the course of the year. And this actually reflects the fact that whenever we place an order, we're going to be ordering 500 units. And we're going to place another order once that gets down to a particular reorder point. And so the holding cost recognizes the fact that whatever we order, we're going to hold for a period of time, and then we're going to have to reorder. While we have it, therefore, during that period of time, we're going to take a look at our average inventory, because that's what our holding cost essentially is going to be applied to. At the point the order comes in, when we get 500 units, we're going to apply our holding costs to all 500. But by the time we get down to where we need to reorder, essentially zero, we're going to be applying holding costs to virtually zero inventory. And so we want to apply it to the average inventory we have on hand, which is going to be the EOQ divided by 2 times the holding cost. And so in this case, we have essentially 250 units on average times our holding cost, which, if you recall, were defined as 20% times the value of any one of those units, $50. And so that suggests, therefore, that we're going to have 250 units on average on hand times a holding cost of $10 per unit, meaning on an annual basis, we're going to incur $2,500 of holding costs. That's the cost associated specifically with holding that inventory over time. And then the last item of interest that we're going to be interested in here is going to be the idea of, well, since this is a fixed order system, when do we reorder? And so what we're going to be looking at here is what is known as the reorder point. Okay? And that reorder point is determined by really 2 factors. One is, how long will it take us to get an order in hand? Because essentially we have that amount of time to use up whatever inventory is left on hand and get it just in time to satisfy the next unit that's demanded. And we also recognize, and we're going to call that, by the way, lead time, guys, the lead time that it takes to get inventory here. And that lead time essentially is going to represent the amount of time we have to sell. And we want to then take a look at how much we think we're going to need to sell during that lead time. And the problem tells us that our lead time at this location is going to be 1 week, and our demand per week is 250 units. So if it takes us 1 week to get our inventory on hand, and we're going to estimate that we'll sell 250 units at that point in time, what we're going to do is look at our inventory, and whenever it gets to 250, we're immediately going to place an order for our EOQ, which we identified up here was 500 units. Okay? So the most efficient order quantity is going to be 500 units. That's going to lead us to place 25 orders per year if our estimate of our forecasted demand is accurate. We're going to incur some costs here in holding costs because we're going to have to work that order of 500 units off over a period of time. And actually, it's going to take about 2 weeks to do that, because our estimate is that each week we'll use 250 units. I'll have to make an order with 1 week to go, because I think I'll use 250 units at that point. By the time I receive the order of 500 in 1 week, I will have used up the last 250, and we start the cycle over. EOQ. Now, problem 3 is going to ask us to do essentially the very same thing, this time for a company called G-Tech. And again, if we remember, we need an estimate of our demand to think of how we're going to run this problem. Now, in this case, they give us the demand at G-Tech as 250 units per month. That would be 250 times 12 to get an annual estimate of demand of 3,000 units. We want to make sure that we also understand what our holding cost is going to be. And so the problem tells us, in this case, that our holding cost is going to be equal to $60 per unit. So using our variables, AH is going to be 60 per unit. Now, they didn't make us go through the calculation of a certain percentage times the value. They've just given us that number to work with. Makes the problem a little bit cleaner. They also help us out by telling us that our ordering costs are going to be 100 per order. And again, these are the 3 variables we're going to need to do any type of EOQ calculation. So, since we have all our variables in hand to calculate EOQ, it becomes just a factor of remembering our formula, which is going to be 2 times annual demand times the ordering costs, all divided by holding costs. And for us, therefore, it's going to be 2 times 3,000. That's our annual forecast demand, times the ordering costs of 100, all divided by the holding costs of $60 per unit. If we're going to rough out the math here, our annual demand of 3,000 units is going to be the factor for us here that allows us to calculate our numerator, which is going to be 2 times our annual demand of 3,000 units times our ordering costs of 100. And that's going to give us 600,000. So our numerator is going to be 600,000. The denominator in this calculation is merely the holding cost. That's going to be 60, which is going to give us the square root of 10,000. And that's going to equal an economic order quantity of 100 units. So the order quantity that minimizes all the costs associated with the inventory is going to be 100 units. And if we look at just the sequence of questions that are asked again, the orders per year, clean that up a little bit, is going to be nothing other than annual demand divided by EOQ, which is going to equal 3,000 divided by the 100 we calculated just above, 100 units, so our orders per year are going to be 30. Next question asks for holding costs. Again, we recognize that since this is a fixed order system, we're going to order and work down to a particular point, then reorder when we have sufficient lead time and work down. And so our holding costs essentially are going to be applied to the average inventory we have on hand, which at its height is going to be the economic order quantity that we place Since we're going to work that down essentially to 0 before we reorder, we're going to divide that by 2 to get an average inventory on hand and multiply that by what it costs us to hold that at any particular time. So we can take a look at this very simply by taking our economic order quantity, which we determined was 100 units, giving us an average holding period by dividing it by 2, and multiplying that by the holding cost, which was given in the problem as $60 per unit. That's going to be, on average, 50 units in inventory at any particular point in time, times that $60 per unit, which means on an annual basis, we're going to incur $3,000 to hold inventory, annual holding costs. And the last part of the question then becomes the calculation of, well, if this is a fixed quantity system, I need to know when to reorder it. And again, that reorder point is going to be a function of two variables. It's going to relate the lead time, how long it takes us to get an order in hand, times the demand we expect over that period of time. And again, the problem suggests that our lead time in this case is going to be 1 week, and we know that on average we're going to be looking at demand of 60 units per week, and that means therefore that when our inventory, when we look at it and it hits 60 units, we're going to place an order for 100 units, and that's going to give us the ability to minimize the total cost associated with inventory. And we'll place that order again when we work our inventory down to a level of 60 units. And that's the value of the reorder point. Gives us the point of time, the fixed point at which we place a fixed order system.